Good morning. Good morning, David. Thank you for watching. I'm upgrading the schematic of the current monitor because the prototype didn't work as expected. So this is a repair, a small repair work. Good morning. Good morning, Sean. How are you? No, I don't. Okay, the question lacks the background. What is the signal source? What is at the input of the logic gate? I missed the complete picture. So the general answer is no, but please be more specific. Oh, thank you. Thank you for watching.
Listening, head over to brain.fm or follow the link in the description below.
Hello, hello, how are you? Thank you for watching. Yeah, thank you for the question. Thank you for your interest. I'm working on the second version of the current comparator circuit. I made some mistakes in the previous prototype version. I swapped the inputs of the window comparator and forget to place some test points, etc. So yeah, I had to modify the circuit for the second version. And the schematic was modified. Not a big change is the circuit. Let's say 50% of the circuit worked, but the window comparator didn't, and there are two signals, charge and charging. It should monitor like the higher current at 1 milliamp is marked as charging, and the band between 0.1 and 1 milliamp is marked as charged, like there is some current flowing into the device, but it's already marked as charging, as charged. So in the band between 0.1 and 1 milliamp is charged, like the finished charging, and above 1 milliamp is charging. And the window comparator didn't work, so only the charging indicator was correct, and the band detection didn't work. So I modified the window comparator, added some test points, and now I'm slightly modifying the PCB layout for this. And frankly, I'm not in a great condition today. I feel like my brain is somehow blocked. So I am looking for words, and yeah, I'm somehow confused, but I think I will be able to finish this change. Yeah, it's not a big deal, but yeah, I don't feel like I'm sharp today. Thank you for asking. What are you working on? What's your project on your desk now? Please tell me, or yeah, comment. Please give me a clue about your job. As a bonus to all of you, I found today a cool feature, cool function of the footprint editor. Let me show you. When you open a footprint, and yeah, I downloaded this footprint from the 𝗬𝗐𝗐𝗐, and they they numbered the pins like with the leading zero notation. So instead of 1, there was 0, 1, 0, 2, etc. So let me revert this change slightly. Like the footprint look like this. So before I found this feature I'm going to show you, and I discovered it today, I change the properties of each pad and change the pad number manually. But there is a function. You go to edit, renumber pads. The prefix is not important. First pad number will be 1 because I changed the entire sequence from 1 to 9. And numbering step like increase, the numbering step increment is 1. So now the function is armed, and click, click, click. By one click, you change everything you want, and then double click to finish. Easy. So I changed the 9 pads in a few seconds, and it was done. And before, I spent a minute by manually changing 9 pads by deleting the leading number, leading 0. So it seems that the KiCad is filled with interesting functions I haven't used yet, still, and I'm always surprised when I found some gem like this. Frankly, KiCad is still missing some important features, and sometimes it doesn't make your way easy. Like when you grab a footprint in the previous versions, you always grab the footprint in the center point. Now you can grab anywhere, but the feature in the previous version was that if your cursor was close to the center, it was snapped to the center. So you always snap the footprint at the center, which is very important. Now you don't. So you can only estimate when the center is, then grab the footprint and align with the neighboring footprint if you want to align the footprints. Sometimes, for instance, for resistors with the defined Cartesian layer, I grab at the corner of the Cartesian and align the corners. But the things like test points doesn't have the Cartesian. So sometimes the red SNES wire help me. You can see that the red SNES always lead to the center. But here is the issue. You can see that I am at the finest raster, 1 mil, and still my cursor is not in the center. Its center is somehow slightly above. So yeah, this is what pisses me off on KiCad. So sometimes it's surprisingly user unfriendly, but when I found a feature like this, the renumbering function in the footprint editor, I am always surprised. So yeah, it's like love and hate relationship, but still there is more love than hate. Good afternoon, Mark, or morning. I am slightly modifying the current monitor, current comparator board I designed 2 months ago. I verified the prototype last week, and half of the comparator didn't work because I swapped the inputs of the window comparator. So now I'm making this, I'm working on this changes of the window comparator, plus I added some test points, reconsider the entire design. It seems that like 50% of the design worked, maybe 75. One of the comparator didn't work, the window comparator. So now I think the schematic is ready, and I'm working on the PCB layout, but today is not my sharp day when I'm on the top, let's say on my prime. So I sometimes looking for the correct word, sometimes like doing missteps, or yes. Now I'm modifying the tracks, but without the symbol editor, the schematic editor visible. I only guessing where the tracks should go, but I will manage to do it. Yeah, here is an issue. Let me hide your comment. Yeah, here is an issue. I renamed one of the label, but not everywhere. So this is why I was confused. Doesn't match. Okay. So let's update all the symbols in the schematic. How it looks now. Input power pin is not driven by yeah. This is what I sometimes, when you update the symbols to reflect the attribute changes, etc., it's important to uncheck the value attribute, because otherwise all test points will be reset. So it's not needed. So now I undone the update and done without the value ticked. So now there is still charging. This is the correct label. Yes. So only two errors, which is easy to correct. There is a missing power flag. Let me explain. There is input, for instance, of this op-amp, which is marked as power input. And here is a connector which in fact provides the power. Yeah, this is the power driving output, VBus. But the connector pin is set as passive. So this power input pin expects the power output port, but this is not power output port, this is passive port. So when you place the power flag here, it marked the net that the net is providing power for the power input ports. And the same is with the ground. My symbols are usually marked the way, or created the way, that the power, the negative power, the ground, is marked as passive to avoid half of the similar errors. But sometimes there is still missing the power marking flag, because sometimes, yeah, I think even the ground port is set as power input. So it expects power to go flowing into the power input. And when there is a resistor, for instance, here, the resistor is passive. It's not power output. So you always should to add the power flag symbol to mark the net as power providing net. It doesn't affect the function, it only affects the presence of errors. You can see that I added two power flag symbols and all the errors disappeared. It didn't change the function of the circuit, it didn't change anything. It only made the KiCad electrical rule check satisfied. So it's up to you. If you can live with such errors, wave it out or wave them out. If not, add the power flag symbols. Oh, I hope I have explained, and I hope you understood. Here is a comment. Hello, Eric. Hi, Eric. There are usually two options when I want to, or other said, for myself and for projects when I or where I maintain the manufacturing and provide my customers with prototypes, manufacture prototypes, I always order at 𝗲𝗲𝗀, Germany, where my customers is in order of the manufacturing, or if my customer wants me to order somewhere in Asia to get the lower price, I order at JLC-PCB. So two options, two ways, 𝗲𝗲𝗀, and I don't want to show you the middle finger, so 𝗲𝗲𝗀, and the second is JLC-PCB. Now I am adding I'm placing the test points. I added some functional test points inside of the circuit, which were already placed, and now I'm placing the reference voltage test points just for the brief check when powering up the board. So it really doesn't matter where it is. Obviously near the regulator or the reference voltage device, but I placed them near the packages of the reference voltage device. So now I have to add some labels. Now this is charging. Here is, it may be of your interest. I usually change the size of the labels or reference designators to 0.8 or 0.7. The default value is usually 1 millimeter in all the standard KiCad libraries or in some of my libraries. If I want to like align all the labels or reference designators to the same identical size, I use the edit text and graphics properties, choose or check the reference designators in layer silk screen. Layer will be unchanged and width will be 0.7 and height will be 0.7 with the thickness 0.1, I guess, and apply. And all you can see here was 0.1, and after the change here, undo, redo 0.7. So it affects all the reference designators on the board, so you can save a significant amount of time. So this is one of the edit labels, and I will move it slightly far from the newly placed register to be able to place the designator here. Here is the 1 milliamp 1 milliamp. 1 milliamp label, and yeah, you can see that I placed the new label and it was quite thick. This is why, because I previously changed the default values. There is a board setup, text and graphics default section, and when you edit the silk screen or any other layer numbers, the default values will be changed. So for instance, when you are placing labels near the test points, you can make the text bolder. If you are placing general text, you can make it thinner or narrower. It's up to you. So you save your time because you don't have to change the labels manually, like the label properties. Yeah, this is the, yeah, this should be here, current. Charging 2.5 is here. .0. Here is 1 milliamp again. And this one is 0.1. Okay. So let's check the design rules check. Yeah, definitely. When your customers or your projects are cost sensitive, yeah, it's understandable that you order at the lower expensive supplier. Yeah, naturally. Obviously, I understand. So the design rules checker. 2 warnings. One is the overlapped silk screen, because I usually place the name of the board and the date of the PCB layout creation near the name of the board. You can see I designed this prototype version in May. Now it's July, and I always place the labels to be overlapped without the gap. But from the point of view of the design rules checker, this is an error, and I can see that there is still fully, I forget to update the PCB from the schematic. I said, as I said, today is not my strongest day, but everything has its solution because we have checkers, and the independent checkers discover everything. So you can see 0 errors and 1 warning, which is the overlapped silk screen. Let me sip a little bit of water. So I'm back, and the PCB is almost ready. I used the two-sided PCB standard. This is a normal board. I used the bottom layer as the reference ground with port copper. The top side doesn't have the copper port intentionally. Yeah, I'm checking the state. Yeah, it looks good. Pins number one are marked near all three ICs. 4 of them. Even here is the pin number 1. Yeah, there is. Yeah. I remember when I testing the board, I said to myself that these 2 pads, plus and minus, should be drilled, should be THT, because I wanted to place hooks in the holes. So I'm going to change these 2 footprints, A and B, no, A, and the second one is this one, B. Doesn't near the R9. Aha, it's not. I understand. It's not the plus and minus. It's like more positive side of the shunt resistor and negative side of the shunt resistor. Okay. So this is the different story. Yeah. Now I remember. I placed the ground hook to the mounting hole because the mounting hole is grounded, and the other side was basically at the V bus, which is the plus, the A test point. Yes. So still, I'm going to change these 2 test points to the THT footprints, which will be like a normal THT footprints with probably the round shape. Okay, so I have to play with the labels because the default position of it's basically a header of 1 port of 1 pad, THT header. So now it's like this, so I have to update the schematic. Yeah, and both test points were updated. That's what I wanted. Exactly, that's what I wanted. Yes. In this state, and TP8 is to be deleted, as well as TP9. Yes. Yeah, this is very user-friendly for me because I can hook my testing wires with hooks at the end. There are like micro hooks, and I always hook the the hook to the THT pad. So no soldering and quite reliable connection. I didn't want to use the USB port for the initial testing because it's more difficult to test. When I use the testing wires, I can connect my laboratory power supply, and with a proper current limit, there is no safer solution. So label green, LED red, charging, plus minus 2.5, 3.0 current output of the current amplifier. This is the output to place to connect the load. Now I'm looking at the position of the THT footprints. Probably I slightly displace the footprint closer to the board edge to make the hook connection more convenient, like this, and for these two as well. It's not a big deal, just slightly, because the reliable testing is quite important for me. So, okay, looks better. 1 milliamp, 0.11 milliamp, charged. Okay, this is the current comparator works like the following way. When there is a charging, I think the LED is constantly on. When the current is higher than 1 milliamp, I think. Yeah, let's see the schematic. I think I'm lost. Yeah, there is a oscillator with 555. When the charging is 0, it means there is no charging, so the charged device is fully charged. The oscillator is blocked, is a reset. And when there is a combination of the charging and charged, the way that the green is at the high level, this MOSFET is blocked. So there is no power for the red LED. So the charging input blocks the blinking, and the green label, the green signal blocks the disables the red LED. So yeah, I think, yeah, charging in the band between 0.1 and 1 milliamp is blinking when, no, not blinking. The blinking is when there is charged. Yeah, the charged is constantly let on because the green, I'm lost, I don't know. Yeah, the reset means that the output is 0. And because the red LED is biased to 5 volt, and when the output is 0, like a low value, the LED is on. Okay, so when the device is charging, but this is the inverted input. So when there is no charging, the red LED is on, but when there is green signal up, like 1, it means that the device is charged, the LED is off, and the green is on. Yes, so when the device is charged, the green is on and the red is off, and when the device is charging, the LED is blinking. Yes, something like this. Oh, I designed it in May and I don't remember anything. Okay, so again, PDF, ERC again, 0, fine, board again. I have to place the drill origin and the grid origin. Okay, there is the design rule checker. One warning, overlap select screen, I can live with it. Okay, so yeah, the board is ready for manufacturing. I will let a few probably days or hours reconsidering the design if I didn't miss anything, but I think the device is ready for manufacturing. Sometimes it's faster and cheaper to let it manufacture and test it in comparison with never-ending testing, not testing, thinking about it and considering the design and calculating. When there is too many projects, you want to push it to the production and test it in the manufactured version. So, okay, the board is ready. So, thank you for watching. I think for today it's fine. As I said, I'm not in my prime time today, but I believe you learned something. If not, I'm happy that you were here. So thank you and have a nice rest of the day. Bye.